Hello. And I'm glad that you set me up so well, because we might be planet scale, but I'm not going to tell you about how we use Kubernetes, because of course we build our own. My name is Johan. We got that covered. I work for Uber in Denmark. And the first question I get then, but Uber isn't in Denmark. Right? You can't take an Uber. Probably a bunch of you are very annoyed you couldn't take an Uber somewhere. But we have an engineering office of 80 people in Aarhus building infrastructure at planet scale. And I'm going to talk a bit about that. The scale of Uber is that cumulative over the years, there's been around 34 billion trips. We have 20 million trips a day and around 122 monthly active users. So it is at scale. I'm working at Uber's stateful platform, and what that means is that we have a platform called Odin where we run all sorts of database technologies. So we build the platform that allows other teams to run stateful workloads. And we have around 40 technologies. So that's MySQL, Hadoop, some in-house stuff, Redis, all sorts of things. And again, we build the platform that allows the technology teams to operate their databases such that some teams can build some services on top of their databases, and so on until it ends up in an app or on a website. And the scale of our platform is approximately this. We have mostly on-prem hosts. We have around 75,000 servers, totaling around 2.5 million CPU cores, managing around 2 exabytes of storage. And we run around 1 million Docker containers in our cluster. And this is operated as a single fleet. So then things become interesting, right? Could we save a 0.5 percentage point here? It matters. So I'm not going to talk much about the platform itself. You can find other talks about that. But the platform we have is we have a bunch of servers, tens of thousands we just saw, on which there runs an Odin agent. These agents, of course, talk to Odin services that are running in our production environments. And operators can interact through the Odin UI, a web service, or through CLI tooling that we built for it. We use Cadence as a workflow engine to run operations, both initiated by robots and humans. And we, of course, have this magical database, Grail, that I'm actually going to talk about today. There are many other components, right? But this is kind of like some of them. So what is Grail, which is what I'm going to talk about? What we want to do is simplify building robust, easy-to-use operational infrastructure at Uber scale. That's like, OK, fair enough. What we're doing is building an integration platform to provide near real-time infrastructure state access. So as operators, human and robots alike, we want to get insight into what is actually the state of this global giant cluster of servers. So if we have human and robot operators, we want to give human operators the capability to effectively debug and generate insights through exploration. Right? What is actually going on in our production systems? And want to give robot operators, I'm calling it robot operators, services, automation, the capability to effectively and safely make decisions that would allow us to operate our fleet at scale, efficiently and robustly. Right? We manage around 2 exabytes of data. Robustness is important. We have a huge fleet. Efficiency is important. So before we had Grail, we could have some scripts, We could have some services and different configuration systems. And of course, they need to talk to each other. Each need to figure out, what do I get from this configuration management system? What do I get from this system? How do I apply it? How do I work with it? And then we also have tens of thousands of hosts that these systems might want to interact with or get data about. And also, we might want to interact with this, understand this state as operators. And again, this becomes very difficult at scale. So in Grail, we put in all the information, we aggregate it, we make it queryable. And the clever people around this crowd will, of course, say, you build an enterprise service bus, which is not entirely wrong. But we have this unified view into the state of our infrastructure now. So that allows us to ask questions such as, how much capacity do we have across different server types? Or how much capacity do we have across data centers? Again, we are mostly on-prem, so capacity is not necessarily as fluid as if we were completely in cloud. Or we might answer some more concrete questions saying, we have this specific cluster. How is this cluster distributed? Across different hosts, across racks. If this rack goes down, what is the impact on what clusters? Or again, across data centers. Worst case scenario, if this data center goes down, how do I know exactly what will the impact of that be on what clusters? Such that when it inevitably happens, I know how to figure out who to reach out to, how to do the mitigation in like catastrophic scenarios, right? And it's not something that we have to, we start from zero. We have all this data aggregated and queryable. And we can, of course, also use this to do tons of complex debugging. Let's say that some cluster is experiencing performance degradation on some amount of its nodes, of which there can be hundreds or thousands. How do we go about figuring out what are the characteristics of these nodes that are not performing as well? Are they running on different hardware, different kernel versions, different configurations? Are they all placed in the same data center? Are there all sorts of different perspectives on this? So that's, in the abstract, the problems that we're trying to solve, some of the problems we're trying to be able to solve through Grail. So Grail is our in-house graph database. It is one of the tools that the team I'm on maintain. We have around 600 or a bit less stakeholders using this data. We serve around 30,000 queries per second. Of course, the vast majority of these comes from the platform itself. We have more than 300 different sources that contribute data into our infrastructure graph. And we'll get into a bit more into how it gets there. Around 45 million different unique objects at any given time. And we ingest around 6.5 million document updates each minute. And we have a decent uptime. And this data that we ingest each minute is more or less instantly queryable. So that is very, very powerful. That when automation does something, we know it, we can see it in the holistic view, and we can see exactly what is going on. So some of the key attributes about this lovely database. It's a non-durable memory cache, which is the kind way of saying we really try our best to not throw away your data, but we don't guarantee it, which makes it much easier for us to operate. So what we're saying is we are not the source of truth. You should be able to regenerate your data in Grail, but it is very rarely that we have to drop any data, and usually it's because some stakeholder did something they shouldn't have done. We have near real-time querying, as I mentioned. So that means we get real-time access to the state of our current infrastructure, which is powerful as it both allows exploration into the current state and robots, services, automation to act on a reasonably accurate view of our infrastructure. It's globally replicated. So that means that all the data we want is available all over Uber. And it's eventually consistent. So we have a high availability, high consistency. We built on top of the Raft protocol, which is the same that does etcd. This is kind of the properties that allow us to do this. Our two largest consumers is Up, which is our stateless platform, and Odin, as I mentioned, which is our stateful platform. And Grail is run as a sub-project under Odin.
Hi, we are Eficode, and we organize the DevOps conference. What developers really want is to see their software live. Minimizing the time from idea to software delivery really makes sense, whether you invest in CI/CD, cloud-native development, or continuous experimentation and learning. We would love to speak to you about how to remove the pain and uncertainty from your software development lifecycle. You can find us at eficode.com. The links are in the description. Have a great time with the DevOps conference talks.
The primary Grail components that we're doing to implement this is the data sources. We call them providers. They provide data into Grail. They can put objects into a graph that will make them queryable. Then we have an ingestion layer, which handles either pulling data from these providers or handling receiving data pushes from these providers. And this layer routes data the correct places such that we get the replication that we want, we get the ingestion that we want. Then we have what we call the Grail backends, which is our consensus layer. And there are many interesting things to say about distributed consensus and how annoying that is to work with. But basically, this is where we establish a highly available, highly distributed consensus that the data will be consistent. And then we have a query layer, our Grail frontends, which is the aggregation layer and the query engine. So our frontends can tail from any amount of backends such that the aggregated graph fits the use case. So our, as I said, we have the two biggest consumers, Odin and Up, and they both aggregate from different sets of Grail backends such that they get the right amount of data for the exploratory queries and the actions that they need to take. Then less interesting, yes, so data source, they can run anywhere. They are just parts of services or specific endpoints or anything. Our ingestion layer is running on Up, which is our stateless platform. And backends and frontends are running on Odin. So it's all the turtles all the way down, and everything talks to everything, and bootstrapping is interesting. But we're running these components independently, and this also have the very nice property that we can scale the ingestion layer from the query layer completely independently. And that's a very powerful property to have. Yes, and we also have a beautiful website, which could use some love, but where we as engineers can go and we can get a very excellent view into the infrastructure state. I will show some queries later. So what we're actually doing is we're representing our infrastructure as a graph. In this case, we have regions, zones, hosts, services. We have different models for how we model our technology. We have a technology that could be MySQL that has a bunch of instances, which usually serve a set of use cases. And then we have clusters that are the different clusters that represent this instance. Each of cluster is a set of nodes in our terminology, which would kind of be a set of pods in Kubernetes. So a bundle of containers running a single cluster node or pod. And basically, we want to be able to say, well, we have a host, and on this host, there are some nodes that run. They are participating in this cluster is participating in this instance, all sorts of different things. Also allow us to answer questions such as, when we get back to if some nodes are performing badly, might that be because they are co-located with specific other technologies? Or might they be co-located with specific other clusters that have some noisy neighbor issues or something like that? And the way it is set up, we can have different sources that provide objects into our graph database, and different sources can even provide different properties into the same objects. For instance, on a host, there can be many different sources of data on a host. It could be issues. It could be different services noticing something is wrong with the host, and it adds some data that we can act on. So this is a really strong decoupling mechanism for our operation. The items that we're working with is we have objects, they have an ID, they are nodes in our graph. We have properties which are basically JSON blobs attached to the objects. And again, multiple providers can help enrich the same object with data from different sources. So that's a nice property. And that also again means that if I want to provide something new about hosts, let's say we have a new compliance, regulatory requirement, or we want to figure out something. We learn something new that is possible, so we want to add some data about this. The only thing I need to do is to create this service and configure it such that the data it provides will be ingested. And then it's immediately aggregated together with the rest of our infrastructure state. So that's, again, a nice decoupling property. And then we have associations. So that is edges between objects. So an example could be, this host has these nodes running on it. Or the on-call rotation for this cluster is these people. Like, there are many different ways, different relations in infrastructure. So that's kind of what we have. So the data flow is generally that we have some data sources, a service running something or whatever. We do some ingestion where we figure out where the data needs to go. We validate some schema. We made rate limit. We can do all sorts of different things. Then we have our consensus layer. And finally, the data becomes queryable and aggregated in the front end, both available for robots and humans alike. I'm saying robots and humans alike a lot, but it's actually a very, very important property, that it is both the data that we are acting on through automation, and it's the state that we can explore as operators. So if we want to do a simple extraction, getting an object out from Grail, we can here see that we start from infra-host star, which is basically saying, I want all the objects of the type infra-host. On them, I want to decorate them with this data in the Mimir host, which is a service that decorates the hosts. And I want to see the server type of the hosts. And then the second requirement, where, I think I might even have errors. Yes, so we start from some set of root objects, and we do some data selection, and we do some filtering. So in this case, you're saying, I only want the hosts that are our hosts, that are Odin hosts. And in this case, I will get more than one result, because I'm using a wildcard in my root object selector. But here I can see, well, this specific host, it has this ID, and it has this server type. Not a super interesting question, but we get actually some state from our infrastructure. Then we might also want to do a graph traversal. So again, we start from all the hosts. Then we follow the association storage node, which is basically an association to the nodes that are running on this host. Then I want to have the Mimir node to be populated. And again, I want to say, get the technology of the node running on the host, and then a filter on only give me hosts that actually have nodes running. Right, now we're starting to see something. Now I'm able to actually split our fleet into hosts that are actively being used and hosts that are available capacity. Again, not the most interesting query at all, but we're getting somewhere. We're actually getting insights into what is exactly the state of our fleet right now. And we can do all sorts of interesting stuff. We can aggregate data during a reduction. Here I just say, well, let me get the length of the list of nodes. So here I can say, give me the list of nodes where the node count is more than 0. And I can remove this from the result. Usually you want some things in your result, but it's very nice to be able to have some conditions and some intermediate results that are not contaminating the result in the UI if you're a human user, or if you want to reduce the amount of data that's transferred to the client if it's a service user. So we can do all sorts of interesting things, and we can flatten our results. We have this is called, of course, the database is called Grail. So our query language is, of course, called YQL. For obvious reasons. This has been developed in Aarhus, Danish city. So originally the database was called Yggdrasil, like the tree in the Norse methodology. But Uber is an American company. So when we were talking about Yggdrasil, no one is able to pronounce that, but we still have YQL for obvious reasons. Naming is hard. So this is a YQL query that does some data query. Again, not necessarily a super interesting query, but we get some manipulation handles. But then we also have more interesting functions. So in this case, I'm starting from the zone bus39, a name conveniently made up for you. I say, give me all the hosts in this zone, in this data center. On all these hosts, give me, follow the association storage node where the node belongs to the technology Cassandra. And again, I want to see the hosts where there are more than one node running the Cassandra technology. And then I get the server type out of the host, Mimia host field. And then I say, give me the distribution of values of this. Right? So for the more abstractly, for the technology Cassandra in this zone, what are the server types that are in use? This could be used for all sorts of different things. It could be for specific clusters. Should our high-performing clusters that have different requirements, does the actual distribution of the nodes on different server types match the performance characteristics we want? Or is there all sorts of different data that might be useful for me to figure out? Are there any of these that are running on a RAID 0 layout that shouldn't be? Is there any of these that are running on an outdated kernel version? Right? Let's say we want to update 75,000 hosts to a new kernel version in production, while all clusters keep running on top of them. Then it's very useful to be able to see what clusters are running what, how is this distributed, how can we plan for be able to do that efficiently, quickly, and most importantly, of course, reliably. So these are some of the things that are very useful also as an operator saying, well, this cluster, this technology, something is off. So what can I explore? What are my tools for exploring this? And a very powerful tool we have to explore this is Grail. So in brief, through global replication of our infrastructure data, near real-time query availability, so we get concrete insights into a massive infrastructure right now, a decoupled and extensible model, we can scale ingestion and query independently. It is trivial to decorate our infrastructure graph with more data, and a powerful and expressive and sometimes quirky query language. We build, run, and operate a world-class stateful platform at planet scale. So as a final takeaway, unfortunately, I can't, as Kelsey, point to all sorts of open source repositories. This is something we built internally. But I really want you to question whether you're able to get the insights into your current infrastructure state. Not as you declared it, not as you deployed it or as you intended it, but as it actually is. And see what simple tools you can build to be able to get that aggregation, to be able to get that insight. Thank you.